A very large part of our 8th grade math year is spent talking about slope and linear equations. So on this slide, I'll go over how to find the slope and y-intercept if you're given a graph, given 2 points, or given an equation that is not in slope-intercept form. So a quick recap, this equation here is slope-intercept form, and it's called that because it gives us the slope and the y-intercept. The slope is represented by the letter m, and it's always the number that's being multiplied by our x. Our y-intercept is where the graph hits the y-axis or when our x value is 0, and I'll get to that in a moment. So let's first look at the easier one, and that is finding our slope and our y-intercept from the graph. So as I said a moment ago, our y-intercept, which is the letter b, is where our graph hits the y-axis. In this case, it's hitting at -2, so that would be our y-intercept, or our b. When finding our slope, we're going to draw a slope triangle between any two good points. If I were to use this slope triangle here, I have a vertical 1 and a horizontal of 3. Or if I use these 2 points here, I have a vertical 2 and a horizontal of 6. And the formula for slope is vertical divided by horizontal. And you can see that no matter which slope triangle I used, my vertical divided by my horizontal simplifies to a slope of 1/3. If I were to write the equation for this graph, it would simply be y equals 1/3 x minus 2, because I've used that slope-intercept format to put my slope as the number that I'm multiplying by the x, and that y-intercept is what's added or subtracted onto the end. Now let's move on to finding our slope and y-intercept when given just the ordered pairs, either in points or shown in a table. So let me remind you that slope is vertical divided by horizontal, or if you have numbers, you can do your change in your y values divided by the change in your x's. So first I'm going to label my numbers, and I need to find the change in my y's. To go from -3 up to -2 on the number line is an increase of 1, and to go from -3 up to 0 on the number line is an increase of 3. So now, according to our slope equation, I'm going to put the change in my y's in the numerator, and I'll put the change in the x's in the denominator. Since this can't be simplified, I know that my slope is positive 1/3. Now our y-intercept is whenever x is 0. If you have an ordered pair and your x value is 0, that's going to reside on your y-axis. For example, 0, 5 is right here, hits the y-axis, so that would be a y-intercept. Similarly, the point 0, -10 would also be right here on the y-axis, therefore making it a y-intercept. So in this case, we can see that x is 0, when x is 0, the y value is -2, which tells us the point is about here, making it a y-intercept. So our b in this situation is -2. Sometimes you'll be given an equation that's in standard form and not slope-intercept form, but you'll still be asked to find the slope and the y-intercept. So what we're going to do here is we're going to rearrange our equation so that y is by itself. So the first thing I'm going to do is subtract that 2x from both sides in an effort to get it away from y. When I do that, the x's go away on this side, leaving me with this equation here. Now I need to get y alone, so I'm going to get rid of this times 5 by dividing by 5 on both sides of my equal sign. On this side, the 5's cancel out, leaving y alone, which is what we wanted. But now on the other side, I have to divide both of these terms by 5. So when I do the 10 divided by 5, I get 2. And when I do -2 divided by 5, that simplifies to -2/5. So now my equation is this, but I still need to pull my slope and y-intercept from this equation, and -2/5 is going to be my slope because that is what's being multiplied by x, and my y-intercept, or b, will be positive 2. Here I'm going to show you how to find the equation of a line if you're just given 2 points. Notice there's no picture, there's no, it doesn't tell you what the slope is, doesn't tell you what the y-intercept is. I'm just telling you 2 points that the line goes through. So the first thing we're going to do is find the slope, and slope is found by doing the change in your y's over the change in your x's, or your verticals divided by your horizontals. So to go from 3 to 6 is an increase of 3, and to go from 2 down to negative 4 is a decrease of 6. So now I'm going to fill in my equation, or excuse me, my formula, and I put my change in y's in the numerator, my change in x in the denominator, and I just have to simplify it. Now that we know our slope is negative 1/2, we're going to use that to find our y-intercept. So notice I've taken that slope and I've plugged it into the equation, and now I'm also going to use one of these 2 points to also plug into the equation so we can find b. Now you can use either equation. You can use either point. I used the first point because it didn't have any negatives, and sometimes the negatives mix me up, or I drop them and I make a mistake with them. So I took my x value and plugged it in for x, and I used my y value and plugged it in for y. Now I'll simplify this side of the equation. Negative 1/2 times 2 equals negative 1. And now all I have to do is get b alone. So the opposite of a minus 1 is adding 1. And when I do that to both sides, these cancel out, leaving me with b equals 4. Now this is my y-intercept. So once I have my slope and the y-intercept, the last thing to do is to put it in slope-intercept form, and that would be y equals negative 1/2 x plus 4. When determining if a point is a solution, there's 2 different methods. So to be a solution means that these values satisfy the equation, or it means that these values work in the equation. And if you have a picture, then we'll see these points fall on the line if it's a solution. So the first one says, is 7, 8 a solution? So since that's within the window of the graph, I'm going to check. I'll go to 7, positive 8, and that would be up here. Since our line does not go through that point, we're going to say that no, it is not a solution because it's not on the line. Now for the next one, it says, is 5, negative 1 a solution? So I'll go to 5 down to negative 1. Since that is a point on the line, then it is a solution. Sorry, my recording paused for some reason. Since it is on the line, the point is on the line, then yes, that point is a solution. Now, the next one says, is 20, negative 4 a solution? Now, my window does not go all the way to 20, or my graph doesn't go all the way to 20. So we're going to use the equation to determine if that's a solution. And I'm going to do this by taking my equation and then plugging those points in. So I'll zoom in a little here. Since x was 20 and y was negative 4, I plugged those into those variables, and I don't know if these 2 sides are equal. If they are, then this point is a solution. If these 2 sides are not equal, then this is not a solution. So I just simply do negative 1/5 times 20, and that equals negative 4. Since both sides of the equation are true, then we would summarize by saying, yes, this is a solution to the equation y equals negative 1/2. Y equals negative 1/5 x.